is not there, na? Okay. Let's start atomic magnetism. Atomic magnetism. Okay. What is this? You have studied Bohr's postulates of atomic theory. Yes or no? Okay. I will use all that. I am considering an atom of one electron, single electron atom. Okay. Bohr assume? He assumed an atom of single electron, na? Means hydrogen like atoms. It may be He plus, it may be Li2 plus. Yes or no? Yes or no? Okay. It is an atom. It is the nucleus. Yes or no? Tell me, what is the charge of nucleus plus the D? Yes or no? Charge of electron is minus, isn't it? Okay. What force will act between them? Is it electrostatic force? Plus charge and minus charge. Means electrostatic force will act between them. Yes or no? Yes, na? At a distance r, radius of the atom. Means electron is revolving in its orbit. Clear? Means according to Bohr, what he said, first thing he said, the electrostatic force between the atom, between the nucleus and the electron will give the centripetal force to revolve the electron around the nucleus. Yes, isn't it? Clear? Which force provide centripetal force? Electrostatic force between the nucleus and the electron. Clear? Okay. mv square upon r, is it a centripetal force? Okay. It should be equal to what? K Z E into E. I am taking the magnitudes, okay? Upon R square. Clear? Clear to everyone? Good. And second thing is that the angular momentum of any electron, the angular momentum of any electron orbiting around the nucleus should be equal to what? H upon 2 pi, integral multiple of H upon 2 pi. Yes or no? Integral multiple means multiple of principal quantum number. Yes or no? What is m there? Principal quantum number of that orbit. Clear? Okay. mvr equal to nh upon 2 pi. Clear? These were two things he assumed. Clear? Clear? Can you tell me what will be the orbital electron? Means if electron revolve around this, means moving charge, na? Yes or no? Is it moving charge? Yes. Okay, sir. If it is moving charge, it will have current. Yes or no? It will have current. It is moving now with some velocity. If it is moving, it will have current. Rate of flow of charge is called current. It will also have current. No? Means current due to motion of what? Electron. What will be this current? I. What will be this current? I equal to E by D, dq by dt, na? Means E by E means how long it takes to complete one revolution, capital T. Yes or no? Is it the current flowing through this, flowing in this circuit? Means circuit, not circuit, orbit, yeah, orbital. Yes or no? Okay. E upon what is T? Time period. What was this? T pi, 2 pi, or you can also take this frequency. Is it is 1 by T means frequency, na? You can also write in terms of frequency. And what is frequency? 2 pi here. T equal to 2 pi upon omega. E omega upon 2 pi. Yes or no? Is all our currents? Yes, no? These all are current. Now, if these are currents, if there is current in a circular loop, is it looking like a loop? And current is flowing in this loop? Yes or no? If current is flowing in this loop, magnetic field will create. Yes or no? Magnetic field will create. What will be the magnetic field? Bn. Because it is in the in one orbit. You can also consider B. Okay, no problem. What will be the B? What will be B? B will be, you know the formula, na? What is the formula of magnetic field at the center due to a current carrying coil? What is the formula? Oh, you guys are looking me. 2 pi means mu naught I upon, not 2 pi r, it is 2r. 2 pi r for which? Straight wire, infinite straight wire, isn't it? Okay. Mu naught I upon 2r. Is this the magnetic field? Yes or no? Okay. Mu naught upon 2r it is. Can you put the value of r and 2 here? I and 2 r. What is the value of I actually? In terms of this, you can put in terms of this or in terms of this. First copy this and then I will cross it. Copy this. Covered? Okay. Okay. You can convert in another one or more form. In terms of V, I haven't converted it in terms of V, na? Tell me, T equal to what? Time is equal to what? Distance by speed. Yes or no? Distance by speed. What was the distance? 2 pi r. Yes or no? Okay. 2 pi r. By speed means it will come up, na? Yes or no? Isn't it? Okay. Put this value here. Means all these value you will get in all forms. Means r is there. Let it be. In the form, in place of I, you can put e by t, na? Yes or no? E by P. Other E F. Yes or no? Mu naught E F upon 2R. Other mu naught E omega upon 4 pi R. Clear? This use. What about this? Mu naught E V upon 4 pi R. Yes or no? Clear? Clear to everyone? I put this to here. You will get what? In place of 2 pi R, it will be, means R square, na? It is R, na? Sorry. It will be R square. R is already there, na? Clear? Okay. You need this. Okay. Equation 2. 1. Let it be equation 1. What about the magnetic moment? Magnetic. This was what? Magnetic field. Na? Magnetic field. Okay. This was current. What about magnetic moment? Magnetic dipole moment. Yeah, moment. Magnetic moment. You know the formula? What was that? Ni. Yes or no? Why N1? Because there is one orbit now only. Okay. What is I here? You know the formula of I. What is that? Here. And what is A? A is pi R square. Pi R square. Okay. Okay. What is I? Actually, I am taking one of these. Only this one. Okay. This is EV upon 2 pi R. What is A? Pi R square. Isn't it? Isn't it? Okay. What will be this? Pi cancelled. R 1 cancelled. EVR upon 2. Means M equal to what? EVR upon 2. Got it? Okay. Now, can I write M equal to EVR upon 2 into M by M? Can I multiply M in numerator and denominator? Yes or no? Now, it will be MVR E by 2 MVR. What is this actually? What is this actually? L, no? Means here. Is it L? Angular momentum. Is it L? Yes or no? It is L. Means E L upon. Oh, there were two M also, no? Sorry. M. Yes or no? 2M. Clear to everyone or no? Clear to everyone? Okay. This is what actually, understand this. Is it electron? Is it electron or no? Okay. Tell me, what should be the direction of angular momentum and magnetic moment? Come to here. What will be the direction of angular momentum of an electron? Angular momentum does it depend on the magnitude of the charge? Is it negative or positive? It doesn't depend. It depends on what? What is angular momentum actually literally? I am writing it here. Vector R cross vector P. Yes or no? Is it angular momentum? Yes or no? It does not depend on the magnitude of the charge, whether it is positive, negative or any chargeless particle. It will have some particular direction according to its velocity and radius. Yes or no? Okay. In which direction it is rotating like? Let's say this is the direction. Okay. This is vector R, na? Yes or no? Vector R is pointing outward, na? Radially outward. And vector V is directing here. Yes or no? This is vector R, this is vector V. Vector R cross P means MV na? What is this actually? Vector R cross M vector V. M will come out. Vector R cross vector V. Yes or no? How you will calculate direction? Vector R cross vector V. Direction of L is away from the board. Clear? Okay. Okay. Means it is away from the board. What about M? Will it depend on the charge? Yes, definitely depend on the charge. Here is minus, he is not, means it will be negative of this. Because I already told you, if I will calculate magnetic field, it will depend on if it is due to electron or proton. It depends on that or no? Yes, depends on the charge na. Direction will get reversed na. I already told you in magnetic field na, because of electron it got reversed. If it is away from the board, it will become into the board. Clear? It means it will be opposite to the angular momentum. Right? Yes or no? It will be opposite to the angular momentum. It will be into the plane, into the board. Is it clear to everyone? Why? I already told you na, it will always be in the direction of magnetic field. Yes or no? Tell me, what is the direction of magnetic field here? Means current is electron is flowing in which direction? This direction. Current will be reverse of this. Yes or no? If this is reverse of this, it will be into the board. And direction of M is into the board. Direction of M will always be toward the direction of magnetic field. Clear? Clear? And what is the direction of L? Direction of L is away from the board. Yes or no? So you will have to give a negative sign here. Yes or no? If you are talking about vector form, you will have to give a negative sign so that you can make clear. You can make clear that L is opposite to M and M is opposite to L. Yes or no? Isn't it? Clear na? Clear it or no? Okay. Now, if it is clear, copy this one. This one copied. Okay. Now, I will calculate board magnetism. How? Let me calculate. Now, M, if I am taking magnitude only, M equal to what? 2, not 2 actually. E, L upon 12. Yes or no? E. What was L actually? NH upon 2 pi. Yes or no? According to Bohr, what he said? Angular momentum will be NH upon 2 pi. Means this is NH upon 2 pi. Upon 12. Isn't it? Take the constant terms out. E H upon 2, not 2, 4 pi. 4 pi m. I am making it constant. It is, take n out of this. Okay. This constant, or assume that this constant is mu b and into n. What is the value of this mu b? Where mu b equal to what? E h upon 4 pi m. And if you put the value of E h 4 pi m, mass of electron, what is the value of E? 1.6 into 10 to the minus 19. What is the value of H? 6.626 into 10 to the minus 31 joule second. What is the value of 4? You know. What is the value of pi? 3.14. What is the value of m? 9.11 into 10 to the power minus 31 kg. You know every value. Yes or no? Now putting this value 0.923 into 10 to the power minus 23. You will get. Yes or no? Yes or no? And what in which form? In the form, what will be the unit of this? What will be the unit of this? Whatever the magnet means unit of magnetic moment. What is the unit of magnetic moment? For what? ampere meter square. Isn't it? Clear na? So remember this value. It will be used. Okay. Now you got this formula. M equal to mu b n. If you are asked what is magnetic moment, what is this? Bohr's magneton. What is this called? Bohr's magneton. Bohr's magneton. Okay. What is Bohr's magneton? Bohr's magneton is nothing. It is the magnetic moment of an electron orbiting in what? Orbiting in first orbit. Yes or no? Means if you put the value of n equal to 1, what will be this? Mu b equal to m, na? Isn't it? If it is orbiting in first orbit, it will be equal to magnetic moment. It is what? Magnetic moment of an electron orbiting in what? First orbit. Yes or no? Yes or no? Okay, copy this. You got now what we often hear. This is the magnetic moment. What is this equal to? When you will put the value of n equal to 1, you will get m. Mu b equal to m. Means it is magnetic moment of an electron orbiting in first orbit. Copy this. Now you can calculate any magnetic moment of any particle. Yeah, this is also important. If you put the value of angular momentum, you can calculate magnetic moment of any particle, any charged particle, because magnetic moment is always for what? Charged particle, na? Is it for non-charged particle? No. In place of E, you will put Q. If it is rotating with some velocity. If copied, tell me. Copied? Copied? Okay. If copied, then tell me, do you remember the formula of radius of hydrogen atom? What will be the radius of hydrogen atom? In terms of Z and N, if you put the value of Z equal to 1 in terms of N. Okay, I'm asking. Now, Do you remember the formula for first? I'm coming here. What is the energy actually? Energy of an electron in hydrogen atom? Minus 13.6. N and Z. What about N and Z? Z square upon N square. Electron volt. In terms of joule, minus 2.18 into 10 to the power minus 18. Yes or no? Z square upon N square electron joule. Okay. This was the energy of an electron. Clear? What about the velocity? Vn. Tell me fast, everyone. 2.18 into 10 to the power minus 10 to the power 6. What about this? Z by N meter per second. What about radius? Tell me. 0.529 into 10 to the power minus 10. Yes. 0.529 na? Okay. Into 10 to the minus 10 na? Angstrom actually. Okay. Z by Z, not Z. N square by Z meter. Yes or no? Clear? In terms of SI unit. Clear na? Clear? Okay. Okay. You got the formula of I? Yes or no? What was the formula of I? Current IN. If you are talking about I, what was I? Current. If you are talking first orbit, second orbit, third orbit, what was I? E by T na? What was T actually? Time period. Time period of means nothing. It is F na frequency. Means if you are to calculate the numerical value of time period, what is this? 2 pi R upon V. What was 2 pi? What was R? Put this value 0.529 into 10 to the power minus 10. What about V? 2.18 into 10 to the power 6. Isn't it? What is this for R? N square by Z. What is this? Z by N. You will get what value? Z square N cube. Yes or no? This is for velocity na? And this is for radius. Yeah, N square by Z. Clear? Means N square N cube by Z. Okay. Means what is the numerical value here? 6.6 I think. What will be the no 6.6? It will be in numerical some fraction. What is the numerical value if you want to calculate in 5 to just 10? Yes or no? Means 3.14. Okay, 3.14 into 10 divided by 2.18. Almost 1.5. Yes or no? 1.5 into 10. Washroom? Yeah. It will be 10 to the power what? Minus 16 and 1 10 here. It will be minus 15. Yes. Yes or no? Second na? Isn't it? Isn't it? Yes or no? Yes sir. What about frequency? And power of Z and N cube upon Z square. What about F? Frequency. What about F? Frequency. It is 1 upon T na? What is the value of T? Minus 15. Divide into N square. N cube upon Z square. N cube upon Z square. Okay, what will be the value? It will come up. Yes or no? Means 10 by 15 into 10 to the power 15 15 z square upon n cube. What is this value? 0.66 into 10 to the power what? 15 or 16? 0.66 will be yeah, 0.66. Okay. Is it clear now? 10 to the power minus 16. 10 was there. Oh, sorry. It was 1 na. Is it clear? It was 1 na. 5 into 2, 10, 1. Yes or no? I took 10 here. It's okay. Okay. There will be minus 16 na? Yes or no? Minus 16. Now it is minus 16. It is 16. It will be 16. Yes or no? Now it is n cube upon z square upon. Yes or no? This is the frequency now. What you got? Frequency 6.6 into 10 to the power 15 z square upon n cube. What will be the unit actually? Frequency unit is what? Cycle per unit? Cycle per second. Yes or no? Per second na? Unit is per second. Here it is second na? Here it is second. Clear? Now tell me the current. I want to calculate current. What will be the current actually? E by T? Yes or no? Or E into F? Now you have the formula na? You have the formula na? What is the formula? E, what is the value of E? 1.6 into 10 to the power minus 19. What is the value of F? You got this 6.6 into 10 to the power 15. Whatever this is, that number z square upon n cube. Now it is what? 6.6 into 16. Multiply it. What you got? 6.6 into 16. 6, 15, and it is 10. What is the point? 105. Huh? Oh, point is also there, na? Yeah, 10.56. 10.56 into 10 to the power what? Minus 4. Z square upon n cube. Here 1.05 or 06. 1.06 into 10 to the power what? Minus 3. Z square upon n cube is the current. Yes or no? Yes. Means if I am putting the value of n equal to 1, z equal to 1 for first orbit of hydrogen atom. Yes or no? First orbit of hydrogen atom. Hydrogen atom z equal to 1. First orbit n equal to 1. What will be this current? I1 1.06 milliampere. Yes or no? This is ampere, no? Yes or no? Is this the value? Now you can calculate the magnetic field. I don't have space. First copy this. You can calculate. You knew the formula of this energy. You knew the formula of this. You knew the formula of this. Using this, I calculated time period. I calculated frequency. I calculated current, and I will calculate magnetic field. Clear? So that you can have in formula in terms of n and z, and this type of formula relation, it will be helpful, very helpful in that examination. Okay, copy this. Copy. Fast. Actually, our vital current is 0.96 milliampere. It is given. We did some mistake. Let me check. We got correct expression. EF. What is the frequency actually? 6.6 right? And 1.6 into 10 to the minus 19. EF. After multiplying with this, is it the correct expression we got? Yeah. Copy. First copy. If there is the error, I will tell you. 0.96. Not fair. You got correct. Incorrect information. How? We got correct now. Is there any error? No. Means in your textbook it is wrong. Okay, this will be 1.06. Clear? Milliampere. This is correct. You found any error in calculations? No. It is correct. Clear? It is correct. In your textbook it is wrong. 1.06 actually. Clear? It is 0.96 given. It is incorrect. Milliampere. Okay, let's calculate magnetic field. Copy this one? No? Okay, copy this one. It is equal to what we got 1.06 milliampere. If in terms of Z, what is there? Z is square upon n cube. In terms of Z, milliampere. And I will write what? Magnetic field. dN it is In, it is dN. Bn will be what? Fn. You already have Fn. What is Fn? Fn is what? 6.6 into 10 to the power 15. And Z is square upon n cube per second. Cycle per second. Every data you have. What is Bn actually? Let's calculate it. Let's calculate the value of Bn. Copied? If copied, tell me. Okay, I'm stepping it up. Now calculate Bn. What is the value of Bn? what will be the value of Bn? Bn equal to what? Bn equal to, what is that? Mu naught I upon 2 r na, isn't it? Mu naught, what is the value of mu naught? Mu naught is 4 pi into 10 to the power minus 7 into I. What is the value of I? We got 1.06 milliampere. Let's put the value of 1.06 into 10 to the minus 3 ampere. Yes or no? And in terms of what? Put this z square by n cube 2. Okay? Clear? Clear to? Oh, sorry. No, in place of no, it's okay. Z square upon 2 into what? R na? What was that? 0.529 into 10 to the power 10 to the power minus 10. What was that? N square upon Z. Now you can calculate. This will be Z cube upon n power 5. Yes or no? Now calculate the numerical part. 5 into 10, is it 1? Yes sir? Okay, 1. 10 to the minus 10 will left here. Okay. What about this? Is it 3.14? 3.14 into 4. 4. Approximately 12 point something. Yes or no? 12 point something. 12. Okay no? Means 12. Into what? Into what? 10 to minus 7, minus 10, and here it is minus 10. Got cancelled? Got cancelled or no? Z cube upon n power 5. Means I got Bn equal to 12 what? Tesla na? Yes or no? Is it 12 Tesla? Exactly the value is 12.8. Exact value is 12.8 Tesla. Clear? Clear? Exact value is 12.8 Tesla. In terms of Z, N and Z, very useful. It is n power 5. This can be asked directly. Is it clear? What is the power of n? Okay, it is power of inversely proportional to n power 5 and directly proportional to z square, z cube. Clear? This is the value of n. If I am putting n equal to 1, what will be this value? 12.8 na Tesla. Clear? Clear to? What about magnetic moment now? You can calculate magnetic moment. You have formula na magnetic moment formula. I am rewriting it. What is magnetic moment? Mu b into n. You have that formula. We have calculated this one. What is this? What is Bohr's magneton? What is the value of this? 0.923 into 10 to the power minus 23. If you put the value of n equal to 1, it will be this one na, ampere meter square. Yes or no? You got every value. You got every value. What is Bn? Bn equal to 12.8 Z cube upon n power 5 Tesla. What is M equal to? Mn equal to 0.923 into 10 to the power minus 23 ampere. N na? Is it N? N. In place of Z, what will be there? Oh, I haven't put Z here. Oh, no problem. It is what? Ampere meter square. Can you do one thing here? You just do one thing here. It is your homework. You find in terms of Z here, this one. Magnetic moment in terms of Z. Here N is given. Yes or no? Find this value in terms of Z2. Clear? It is your homework. The process followed by the process to me. Okay? Same as the same process I followed. Okay. Okay. Do it. Yeah, sure. Copied? Now, one more thing, and after that, I will give you few questions. Do a proper note, okay? Now, what? What happened? Oh, wait. You haven't copied this? Copied now? Okay, no copy. Now, I told you now what is the magnetic moment. What was it? E L upon 2m. Isn't it? Isn't it? Yes. What is L here? If a particle is rotating in a circular path, what will be L of that particle? E I omega by 2m. If you know the what is I here? Moment of inertia, and omega is angular velocity. If you know the moment of inertia of that geometry, you can calculate the magnetic moment. Yes or no? It may be spherical, it may be hollow spherical, it may be what? Cylindrical, it may be what? It may be disc. What is I of ring? I of ring? mr square. Yes or no? Yes or no? Ring. Oh, you haven't studied this. I will teach this, don't worry. But do you remember the formula? Moment of inertia of ring. No, na? No. I will teach it. Then I will. Okay, I am writing it. Just copy this for your calculation purpose. But I will teach it later in the chapter. Okay, I haven't taught you moment of inertia because that is in kinematics and dynamics, all those rotational motion and all those. I haven't taught this. Okay. Okay. Now just copy this only. What is the moment of inertia of ring? mr square it is. What is the moment of inertia of disc? Disc. It is mr square upon 2. What is the moment of inertia of cylinder? It is mr square. What is the moment of inertia of solid sphere? Solid sphere. It is what? 2 by solid sphere na 2 by 5 mr square. Hollow sphere, moment of inertia of hollow sphere is 2 by 3 mr square. Remember this. Okay, 2 by 3 mr square. I will teach it later, don't worry. But for now, just copy as it is so that you can memorize it. Okay. Now solve few questions. Copied? Now solve the question. If copied, solve the question. Remember all these formulas, okay? All the moment of inertia formula. Clear now? Because these are going to be used repeatedly. So remember all this. I will prove it why this is mr square, why this is mr square by 2. Because I will taught this chapter. I will not discuss about this right now. Okay? If you will get confused. Okay. Copy a question. Solve this question. A helium nucleus is a helium nucleus is moving in a circular path of radius 0.8 meter. A helium nucleus is moving in a circular path of radius 0.8 meter. 0.8 meter. Full stop. If it takes 2 seconds to complete one revolution, if it takes 2 seconds to complete one revolution, if it takes 2 seconds to complete one revolution, full stop. Magnetic field produced at the center of the circle is magnetic field produced at the center of the circle is magnetic field produced at the center of the circle is can you calculate this? Can you calculate this? Use the basics. Yes or no? Solve it. What will be the current? What will be the current? Solve it properly. Don't do cross talks. Solve it. Solve it. Radius is 0.8 meter and time is 2 seconds. Okay, I'm solving it. Solved. Got the answer? Got the answer or no? I'm giving the options. I'm giving the options. In terms of mu, calculate in terms of mu into 10 to the power. Mu into 10 to the power minus 19, one option. Mu into 10 to the power minus 9. What is this? Tesla. Mu 10 to the power minus 19 by mu Tesla. 10 to the power minus 19 by mu not Tesla, and the third option is 2 into 10 to the power minus 19 Tesla. Fourth option is 2 into 10 to the power minus 19 by mu not Tesla. Means option 1, 2, 3 and 4. 1, 2, 3 and 4 are there. Okay. These are the options. Now I'm solving, don't worry. I'm here to solve. No? I'm here to solve. No? You solved or no? No, sir, no problem. Come in, sir. Come here. T is what? Given, na? 2 seconds. And R is also given. Radius given, na? Or charge given? Radius given. What is this radius? And what is helium nucleus, na? The question is asking for what? Helium nucleus. Means charge is also given. What is charge of helium nucleus? Tell me. Is it? What is charge of helium nucleus? Plus helium has 2 protons. No? Yes or no? And because it is talking about nucleus, it will not have electron. No? Only 2 protons. Plus 2e. Isn't it? Isn't it? Yes. Now you have the answer. You are asked to what? Calculate what? B. B na? B equal to mu naught I upon 2R. Mu naught I. What is I? Q by T. What is Q? 2E by T by 2R. Now mu naught 2 mu naught E upon 2TR. You have everything now. 2 mu naught E 1.6 into 10 to the power minus 19 coulomb divided by 2. What is T? 2. What is R? 0.8. Now you have the answer. What is this? Clear? 2 ja 8 2 ja 16. Okay. 2 got cancelled. 2 got cancelled. Mu naught into 10 to the power 19 minus 19 Tesla is the answer. Is this the answer? Yeah. This is 9 or 19? Oh, this was 19 actually. Option A is correct. Clear? Clear now? Okay. How you use this concept? I already told you this concept na? Yes or no? And no? I didn't tell you I equal to Q by D. No. I didn't tell you. Tell me honestly. Okay. Make sure you understand everything I am teaching here. Okay. If you don't get, tell me. I will repeat it again and again. Okay. I'm here to make you understand everything, not only to deliver the lecture. Okay. So you can ask anything. Copy it? Okay. Solve another question. This will be the last question. A particle of Q, charge Q, a particle of charge Q, mass M, charge Q, mass M, is moving in a circular orbit with angular speed omega. With angular speed omega. With angular speed omega. Full stop. The ratio of its magnetic moment. The ratio of its magnetic moment. The ratio of its magnetic moment to that of its angular momentum. To that of its angular momentum depends on Option A depends on a particle of charge q and mass m is moving in a circular orbit with angular speed omega, full stop. The ratio of its magnetic moment to that of its angular momentum depends on option A, omega and q. Option A, omega and q. Option B, omega q m. Omega comma q comma m. Option C, q m. Option C, q m. Option D, omega m. Option D, omega m. This is A, this is B, this is C, this is D. Okay, solve it. Solve it. Solve it. Solve it, everyone. A is correct answer. Okay. About means he said A is correct. Let me check. You guys, what about you? You got the answer? Shahid, solve it properly. Easy question it is. Oh, okay, I'm solving. Don't worry. I already gave you what relation, what m equal to E L upon 2m. You have L or m. You are asked to calculate what? M by L, na? Or L by m. You are asked to calculate what? The ratio of magnetic moment to that of angular momentum, means m by L. What is this? E by 2m. What is given in the question? Q, and charge is Q na, not E. In place of E, what you will do? You will put Q na? Yes. Means in place of E, it is Q. In place of M, it is M. It depends on what? Q and M. Q and M. C is correct option. Yes or no? You have the formula, you should know the importance of formula. Now I already told, gave a star in this formula, yes or no? Why I gave a star in this formula? Because there is some importance, no? And if you don't know the formula, go with the basic. I already derived that, na? From where I derived, you know, na? You have everything in your copy. Go with the basics. If you physics is very difficult. Actually, not difficult. You guys don't take it seriously. Okay? No problem. Let's start magnetic substance material. Magnetic material. Oshu? Okay. You guys go, and I'm also coming from Oshu. Okay. I will start first. What it is? Actually, magnetizing field means the field, not magnetic field. Actually, the part of the magnetic field, not exactly the whole magnetic field you applied there. The part of the magnetic field that is used to magnetize the material. To magnetize the material. Clear? Getting my point? Means no. No, sir. Okay. I will understand, make you understand. Tell me, I applied magnetic field B here. What? B here. Okay. And a substance is placed here. Yes or no? A substance is placed here. This, the magnetic field, this is outside magnetic field. Yes or no? In this region. Yes or no? the field that goes with this crosses this region is used to magnetize here, this no, yes or no, and rest are not using, rest are useless na. The field that is used here to magnetize this is called magnetizing field, yes or no, and this is nothing, this is H, this H is equal to B divided by mu naught. If it is in air, if it is in air, then divided by mu naught. If it is in medium, if there is some medium, it will be mu. Yes or no? It will be mu, not mu naught. Got this? Yes or no? Clear na? Okay. Second thing you should know is what? Intensity of magnetization. Intensity, different thing. Magnetic intensity and intensity of magnetization are different thing. ठीक? Intensity of magnetization. Intensity of magnetization. What is this actually? This is denoted by I. What is this actually? Again come here. This was the material na? I placed in between in the space of magnetic field. Clear? Some of the field lines goes passing through it. Yes or no? Passed by through it. Yes or no? Due to these magnetic field lines, it will have some magnetic, mean it got magnetized or no? It will got magnetized. Yes or no? The magnetic field inside means whatever the magnetic field, it got magnetized. It got magnetized means it will have some magnetic field its own now. It will have its own magnetic field now or no? This is called intensity of magnetization actually. Whatever the magnetic field he got magnetized due to the presence of what? Magnetic intensity, means magnetizing field. Yes or no? This magnetic field is called intensity of magnetization. Clear? Whatever he got, clear? Due to the external magnetic field, whatever he got is what? Intensity of magnetization. It is actually, numerically, it is actually magnetic moment per unit volume. Sorry, per unit. No. Let me see. Numerically, it is per unit volume. Yeah, per unit volume. Sorry, per unit volume. Clear? Per unit volume. It is. What does it mean? It means the magnetic field he obtained due to magnetization. Clear? And numerical or mathematically it is what? Equal to magnetic moment. This moment, from where it magnetic moment came in this material? Due to magnetization na? Due to the external field na? If it got magnetic moment, it also got magnetic field. Yes or no? Inside it. Yes or no? And this is numerically equal to this. Clear? What is this actually? IA na? Yes or no? NIA? Yes or no? Okay. This is also IA by, this is volume. Okay? Volume. Write it. Copy this. This one and this one. And what is the unit? What will be the unit of magnetizing intensity and magnetic field? Unit, SI unit. What will be the SI unit? Tesla. And what about this? What about this? Tesla meter per ampere. No? You forgot. What is the unit of mu naught? You don't revise. What is the unit of mu naught? You should remember this. Mu naught. Tesla meter per ampere. Was this? Now what will be this unit? Ampere per meter. Yes or no? Ampere per meter. And another unit? What is the unit of B? There it have Tesla first, दूसरा second Weber per meter square. Yes or no? Weber per meter square. I will teach it. What from where it came? Weber per meter. Weber is the unit of magnetic flux. Weber is the unit of magnetic flux. Now, what is this unit? What will be this unit? Tesla meter per ampere. You also can have this unit from what formula B equal to mu naught Ni. Do you remember? Ni by L na? Yes or no? Means this is what? Mu naught n small n. If you remove small n, it is capital N by L na? What is this unit? Li. L is Tesla. This is meter divided by ampere. Yes or no? Okay. Now it is Tesla meter per ampere. Now you can have another unit. What will be this unit? Weber. Means if you divide them, Weber per meter will cancel out. Weber per Tesla. Weber ampere na? Weber ampere Tesla meter. Yes na? Okay. This will be the unit. Other unit, you can have other units. Okay. Now, what about this unit? Ampere meter square, meter cube. Ampere meter square by. This is ampere na? This is ampere. A means area, meter square. What about this? Meter cube means ampere per meter. Ampere per meter. Yes or no? Means both have unit same no? Yes or no? Both have same units. That's why I told you na, this is also magnetic field, this is also magnetic field. Actually whatever I am giving, it will create that one na. But I am expressing it in another formulas, because here I want to know magnetic moment. Here I want to input what? Magnetic field na? Here why I give input here? Magnetic field. Here what I obtained? Magnetic moment. That's why I am expressing it. But actually both are same thing, because unit have same. They have same units na? Okay. Copied? Tesla? This one? No, this one meter will cancel na? Oh, so meter cube na? It will be meter cube. Okay. Tesla meter cube. Weber. It will come up again. Yeah. Good. Meter cube it means. If copied, then magnetic susceptibility. Third one is magnetic susceptibility. 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 CIBILY. Magnetic susceptibility. This is chi. Not chai. This is chai. Okay. What is this? Chai M. Actually, this looks like peacock. This is chai. Clear? In the form of X, like, yeah, it looks like X, but give it larger tail. Chai M. Chai M. Clear? Now, what is magnetic susceptibility? Understand? Don't confuse with electric permittivity, electric permeability, magnetic susceptibility. Yes or no? Yes or no? Actually, what is electric permittivity? it were allowing the electric field lines. Yes or no? The medium that allow more electric field lines, it will have more electric permittivity. Yes or no? Yes or no? Okay. What about magnetic susceptibility? Susceptibility means if I am putting a material in a magnetic field, clear? If this material have more susceptibility, means it will get more magnetized, na? Yes or no? Means how much it will get magnetized due to the presence of magnetic field is it is what? Magnetic susceptibility, na? It is what? Means magnetic susceptibility means if I am putting a material in a magnetic field, it got magnetized more and more. It means it have more susceptibility. Clear? Clear? And numerically, what should be the formula of this? Listen, magnetic susceptibility is nothing. It is the what we got. If I put this, what it will got? What it will get? Magnetic field means magnetic moment or intensity of magnetization. Yes or no? Magnetic moment per unit volume is what? Intensity of magnetization. It got what? Intensity of magnetization. What? In presence of what? If I applied what? Not magnetic field actually. Magnetizing field. What is that? Magnetic field is, listen, inside this magnetic field, whatever line it will cross will get magnetized, na? Yes or no? Outside magnetic field is of no use, na? Yes or no? That's why it is intensity of magnetization divided by magnetizing field. Clear? Means whatever intensity of magnetization it got per unit magnetizing field. Clear or no? Clear? Yes, yes, yes. Got it? Okay. This is the formula. What is the unit? Is it unitless? Because unit of this is same, unit of this is same. Means it unit less. It is unit less. Clear? Clear to everyone or no? Clear to everyone or no? Yes or no? Good, good, good. Good enough? Okay. Now tell me what is magnetic permeability? You already know. Magnetic permeability of air, you know, na? Of air is mu naught, na? What about mu? I already told you here. Don't get confused. If I am writing it here, B magnetic field of A in, I applied this magnetic field in air, na? If I am applying this magnetic field in a medium, what will be this? Mu, na? And tell me, this mu will be equal to what? dm by h or no? Yes or no? This is what? Magnetic what? Repeat it. Permeability. Don't confuse with the permittivity. Okay? This is what? Magnetic permeability. This is what? Magnetic field inside a medium. What? Magnetic field not in air. Magnetic field inside a medium or in a medium divided by what? Magnetic permeability of that medium. What is this? Magnetizing field. Got it? Everyone clear? Clear this? Okay. Actually, I wanted to know you magnetic permeability. What is magnetic permeability? This is not magnetic permeability of air. This is magnetic permeability of that medium. Of that medium. Yes or no? Got it, huh? Let's calculate magnetic permeability of a magnetic field inside a medium. Got it? Okay. If you got it, then let me come to a conclusion. These are the few basic terms you should have known. Now I will go to another level. And relation between what? Between what? Magnetic susceptibility and magnetic what? Permeability. Okay. Let me get the relation. Let me get the relation. Do you know relative permittivity? Do you remember? Relative permittivity, not permeability I am talking. What was that? What was that? Hey, everyone. I am just comparing it because you can make it clear. Here, do you remember this relation? What was that? Mu upon mu naught na? Yes or no? In the same way, we can also have relative permeability. Clear? Yes or no? It will be equal to what? Mu upon mu. Don't get confused. Clear? So that if you know this, you can also remember this. Yes or no? I want to derive a relation between magnetic permeability and relative permittivity. Relative permeability. Also, actually, magnetic susceptibility and relative permeability. Clear? Okay. Tell me. There are actually, I will teach this later. Now I am introducing one thing here. There are three types of materials, magnetic materials. There are, in chemistry you will study that too. There are three types of magnetic materials. Which? What are the names? First, diamagnetic material, paramagnetic material and ferromagnetic material. If I am talking about diamagnetic material, when I will, is this having any magnetic moment? No, it is zero actually. What about paramagnetic material? Net magnetic moment is zero. But if I am talking about the atoms of the magnetic material, it will have some dipole moment. Yes or no? Magnetic moment will be non-zero. About each atom, not about the whole material. Whole material, it will be zero because of random orientation. Clear or no? What about ferromagnetic material? It already had magnetic properties, magnetic moment. Yes or no? Tell me, if I am applying magnetic field across diamagnetic material, what will be the effect? It will get magnetized but in opposite direction. It will get magnetized but in opposite direction. Clear? What about para? It will get magnetized but weakly in the direction of magnetic field. Yes or no? What about ferromagnetic? It will highly magnetized in the direction of magnetic field. Here I am talking about paramagnetic or ferromagnetic, not diamagnetic. Clear? Okay. I will teach it later, don't worry. To make you understand this, I introduced all three types of materials here. Clear? Now, if a material, I am placing a material in a magnetic field. Okay. If I am placing a material in a magnetic field, now what will be this magnetic field dm? Means here outside is B naught na? Yes or no? What will be Bm? Now after placing it there, Bm will be equal to B naught plus B induced. It will have magnetic field induced in it or no? Yes or no? Why adding them? Because both are in same direction na? If they are in opposite direction, what will be there? Minus. Yes or no? For diamagnetic it will be minus. Yes or no? Okay. What is B naught actually? Do you remember this formula? H equal to B naught upon mu naught. Yes or no? Yes or no? What will be B naught? Mu naught H. Yes or no? What about Bi? Actually Bi is inside now. Bi is inside now. Inside the material it induced now. What is the magnetic field inside? What is the magnetic field it got? I already told you now. One was outside magnetic field. I am material outside me. This was B naught. The material I through me passed is the magnetic field through me that is passed is H. Yes or no? Now what is the magnetic field induced inside me? I na I. That was why I na intensity of magnetization. Actually it will be equal to I will be equal to what? Bi by mu. Yes or no? Bi equal to mu. Actually Bi mu will be there. It will be mu into what? I. Yes or no? Mu into I. It is inside now. Inside. You are talking about inside. This is why this is not H. Why this is not H? Because this is not. You are not. This is induced now. Means inside this material you are talking about. Yes or no? This is the field, outside field that passes through it. This is the intensity of magnetism that induced inside this material. That induced inside of it. There are two different things. One is external thing, one is internal thing. This is internal thing, this is external thing. This is the field you applied, this is the field it induced. Yes or no? Both are different thing or no? Got it? Both are different things. Okay. Now I want to replace it with, do you remember one more formula? Chi m equal to what? I by H. Can I use this here? Yes, I equal to chi m into H. Sorry, H plus chi m into H. And mu is also there, na? Okay, no problem. What can I take from it? Mu naught into H. What about this one? What about this? There was no mu naught, means mu by mu naught. We'll have to divide it. Yes or no? Okay. What about chi m? It will have this value, no? Yes or no? Got this or no? What about this? Mu naught into H? Yes or no? This is what? B naught. Yes or no? 1 plus, what is this? Mu by mu naught is mu r, no? Mu r into mu h. Actually, okay. Mu r into mu. This is mu h. Mu m, no? Mu m. This is bm. What about this? Bm. Oh, don't put B naught here. What is Bm actually? Bm means B material, na? Inside this material. Okay, let me B naught. Okay, let me see. Listen. This will not be mu. This will be mu naught I. This will be mu naught I. Mu naught I. Bi equal to H equal to B naught upon mu naught. I equal to Bi upon mu naught. Now it will be mu naught, na? Yes or no? Making it. Sorry. Here. What is this? mu naught I can take it out, h I can take it out, and 1 plus chi m, no? Yes or no? Okay. Here this is bm. If I am bm, na? Yes or no? This is bm. Understand this. If I am taking mu naught here, bm by h, I am taking h here, or you can take mu naught too. What is mu naught? Any formula you can use. 1 plus chi m. What about this? What about this? Bm upon mu naught. Bm upon mu naught is a formula. H, no? Yeah. H equal to is what? I'm forgetting it. Mu naught H. Okay. I used this formula correctly. I equal to chi m into H. Good. Good. Okay. I took mu naught H 1 plus chi m. Okay. It should be in terms of mu naught. Means this is H, bm upon mu naught. Check it once more. H got out by upon mu naught H. B by H. B by H. Okay. Here. This mu naught, let it be here. H will come out. Bm upon H. Listen, understand me. Don't make noise. Here, this is Bm upon H. Understand it. What is this? Bm means magnetic field inside it. I'm talking about magnetic field inside the material. And H is what? Applied intensity of applied magnetizing field. Yes or no? What will be this relation? I already told you this relation is nothing. This is B by H. Yes or no? But B from where? B material, na? Here, remember the previous slide. What was the formula actually? Mu equal to what? Bm by H. Yes or no? Do you remember the previous slide? Mu equal to what? Bm by H. You got this, na? Now, can you use this formula? Means it is mu actually, na? Mu naught 1 plus chi. Yes or no? Got this idea or no? Why I am using mu not mu not mu? Because this is material, na? Inside this material it is. Clear? That's why it is mu. Why not mu naught? Because it is not in air, na? It is means inside this medium, na? Now can you write this mu by mu naught equal to 1 plus chi m? Now it is what? Mu by mu naught mu r. This is mu r equal to 1 plus chi m. This is the relation you should remember. Okay? Got the derivation? Is there any doubt in any expression? I am making you clear once more. Listen, this is what? Magnetic field. What? Magnetic field inside this medium. Okay? Means total magnetic field. There are two types of magnetic field. One is what? One is applied magnetic field and the other is induced magnetic field. Both are in same direction, na? That's why I did them. What about applied? Mu naught into H. What about the induced? Mu naught into I. Clear? Mu naught into I. I placed what? Value of I here. What is that? Mu m into H. From where? From the definition. Yes or no? Mu means chi m into H from the definition. Means you know the formula, na? This one. Chi m equal to I by H. I took mu naught H common. 1 plus chi m is here. I took H from here to this, from right side to left hand side. this. What about this term? This is mu equal to mu naught 1 plus chi m. Now mu by mu naught equal to 1 plus chi m. Mu by mu naught is mu r equal to 1 plus chi m. Got it? Copy this. Why I derived the relation, you will understand in next chapter. Remember this chapter, relation, because if I will know the value of relative permeability, magnetic permeability or magnetic susceptibility, can I find other value? Yes. If I know this, I can also derive know the other value. So remember this relation. Clear? So keep in mind this relation, mu r is equal to what? 1 plus chi m. Clear? This is all about today. We will discuss the next thing. So tomorrow we have very huge topics are there. Only 1 or 2 topics are there left, and after that we will discuss numerical questions and PYQ papers. So get ready for that and try to solve more and more questions after going home. Clear? Okay. What about homework? You don't practice actually.